episode, we are now trying to solve slightly different equations that are like this. So here we want to solve 2x minus x squared plus 5 is 0, and what we have is still the graph of 2x minus x squared. So you see that what we have on the left-hand side here cannot be interpreted as y like we did in the previous episode. So we'll have to somehow transform this equation into an equivalent one that would allow us to use this graph. To do so here, you see that we can subtract 5 on both sides to get the equivalent equation 2x minus x squared equals to minus 5. And once we've done that, you see that the expression we have on the left-hand side is not the same one as we have for our graph here. So basically what we want the point on the graph for which y is equal to minus 5. Let's draw the line for y is equal to minus 5. So the 2 points we're looking for are here and there. This means that if we read an approximation, because remember that solving graphically will only lead you to an approximate answer, x is going to be roughly minus 1.5 or 3.5. So you see the key here has been to turn our equation here into an equivalent one for which one of the two sides was the expression we had for our graph here. So let's now increase the complexity one more step and try to solve this equation right there. You see that what we have here is even more different from 2x minus x squared than what we had for the first one. The idea is still the same. We need to turn what we have here into 2x minus x squared to be able to use the graph. To do so, we are going to add x on both sides. This will enable us to turn this x plus x into the 2x that we need. And let's also get rid of the 2 by subtracting 2 on both sides. We are going to end up with 2x minus x squared is equal to x minus 2. So what we have on the left-hand side now, like we did before, can be interpreted as the y-coordinate of the point on our graph. And let's do the same on what we have on the right-hand side, and let's call it, for example, y2. And here, stating the y2 is x minus 2. You can notice that this is actually the equation of another graph. It's the equation of a straight line. Let's plot it. So how can we now solve this equation? Well, just try and look at what we have here. For the same x, okay, we have two different y's, and we want these two y's to be equal. So this means that for a given x, y2 is going to be here, and y is going to be there. Okay? We want the y coordinates here and there to be the same. So what does it mean? If for a given x, the y here and the y there is the same, it basically means that we are on the point of intersection of these two curves. You see that for x is minus 1, the y is minus 3, and the y2 is also minus 3. Have a look at the black curve and at the red curve. So this means that at this point here, I can say that y is equal to y2, which means that 2x minus x squared, this is how I work out the y-coordinate on the black curve, is equal to x minus 2, which is how I work out the y-coordinate on the red curve. So, according to my graph, this happens when x is minus 1 or when x is 2. For the second point of intersection is at x is 2. Let's substitute x by minus 1 or by 2 in this equation to check that we do get a solution. When x is minus 1, we have minus 1 minus minus 1 squared, which is 1 again. So minus 1 is minus 2, plus 2 is 0. When x is 2, we have 2 minus 2 squared, which is 4. So that's 2 minus 4 is minus 2, plus 2 is 0. So we have found here the two solutions of this equation. The key was to turn one of the sides into the expression we had for our graph here, to be able to interpret this as a y-coordinate. And this one could be interpreted as another y-coordinate through the red graph. By looking at the intersection of these two graphs, we could find the two values of x for which this equation was satisfied. We are going to push this idea even further in the third and last episode. Check it out if you're interested.